Ms. Sisney, I received your problem. You seem to understand the formula that the load equals the constant times the width of the board times the height squared over the length of the board. And for this particular problem, we're given this info. We're told the length of the board is 12 feet, the width is 4 inches, the height 6 inches, and the length 800. I noticed when you emailed it to me, it looks like you have the length set as 13 instead of 12, and so that could be the problem, is you have a 13 here and it's supposed to be 12. One thing I noticed right away is we need to convert everything to the same unit, so I'll convert these inches to feet like you do. So this would be what? This would be 4 inches would be a third of a foot, so that's the width, and this would be 6 inches would be half a foot. So I'll substitute those numbers in here. Oops. Let's see. The load is the load is 800. K is what we're going to have to find. The width is 1/3. The height is 1/2. And the length, the 1/2 squared, and the length is 12 feet. So I'll have 800 equal K. Let's see, a half squared would be a fourth, times a third would be a 12th. And so that'd be K times a 12th, and since that's divided by 12, 1/12 divided by 12 is 1 over 144. Multiply each side by 144, and I'll get the value of K, which is the first thing I need here. K comes out to a pretty big number, 115,200. And next, I guess I'll come over here, and I'll put that number into the formula. Be 115,200 WH squared over L. And so next thing they do is they give you everything but the length of the board. They give you the load, the width, and the height, and they ask you to solve for the length. So we could just swap these two here. So the length of the board would equal 115,200 WH squared over the load of the board. So you substitute in these three numbers and do the arithmetic, and I guess you get the load of the board. Let's see, what did they give us for those three numbers? For the width of the board, they give us 9 inches, which would be 3/4 of a foot. They give you 7 inches, which is 7/12 for the height, and the load is 1,200 pounds. So I substitute those numbers in, and I should be able to work this out. Let's see here. So the load, or the length of the board, would be, let's see, 115,200. Oops, I forgot the 2 up here. Then if you multiply these two fractions, you square that and multiply, I think I come up with 49 over 192, and this is all over 1,200. I just punched that into my calculator, and I got 24.5 feet for the length of the board. Hope this helps.